yesterday regarding this creation and initiation operators. So we get basically creation and initiation operators, how they act on space, जिसको हम Fock space भी कहते हैं in that sense. So it's a sort of Hilbert space. So अब ये है कि we can have one particle states, two particle states, three particle states, n particle states. So our treatment yesterday was for non-particle states, particles of the same kind or the same type. उनका Fock space कैसा होगा? And in that sense, अगर हमारे पास कोई भी creation operator होगा A dagger or annihilation or creation operator, if there are n1, n2, ni minus 1, ni minus 1. So if a creation operator operates on these states, since it's a one particle states, so other particle n2 and 3 may not be existing out here. So you can have
सर वेट को एलो कीजिए सर
proportional to n1, n2,
मैंने करना चाहिए
n plus 1, and n plus 1. So this is
Yeah, Miss Saraswati
one
बनाई
particle
host, हाँ?
state, with
correct
quantum number.
हेलो सर
The same way for annihilation operators acting on these one particle states, it will be like ni minus 1, ni plus 1, proportional to n1, n2, so on, ni minus 1, ni plus 1, so on. So this is 2.14, 2.15.
क्या हमी
So it may
Can I ask him
include one quantum number.
ना तुम्हें Saraswati ज्यादा क्या बनाऊँ host इसलिए क्या ब्याख तो बनाई
One
पर
particle
करेक्ट ऐड पाने
state algebra है, for example, if a creation operator acts on that Hilbert space or Fock
Camera
space
trial high
or
कर,
vacuum
camera
space.
trial.
Yes. And you to ask something.
यस सर सर मुझे होस्ट बनाइए बाकी वेट कर रहे हैं
Okay, you admit all of them.
सर
No,
होस्ट
sir,
बनाइए
इसने
ना
host है
Host, you are
ये
the
बनाने से
also
हमें
host. So you can have these particle states, you can make, so as a creation or annihilation operator acting on that vacuum state, on the state which is made of only one kind of particles, N1, N1. There not be other. You can have N1 types of particles and do so a creation operator acting on these states. This is annihilation operator, creation operator, this is annihilation operator, it will give this state. अब इसी तरह अगर हमारे पास operator, this creation operator acting on this vacuum state, that is AI dagger acting on this vacuum state, it will be psi I1, so it will be this, you can write it like that, this, it's 0, 0, so on, and I. Because at the end, here, it's 1, 0, 0, 0. So it's for one particle state, it's for one particle state. In the same way, an annihilation operator acting on this Y state, it can be, you can have AI 0, 0, so on, it's 1, 0, so on. So here it will be delta ij psi of 0. So delta ij, so it will have sort of chromatic delta. So if it will be the same, two states of the same, then it will be 0, otherwise it will get one particle state back. So in general considerations, any state which is acting on this vacuum state or any state, whether it's creation operator or annihilation operator, which is acting on vacuum state, it's equal to 0. Vacuum means nothing is existing. But if there are states means psi state, an operator acts on that state, either its states will be higher or it will come lower. By creation operators, you can go and you can have annihilation operators. So इसका algebra ये है. अब मसला ये है, before coming to the algebra of creation and annihilation operators, there is an exercise in the book और which will थोड़ा सा इसी चीज को थोड़ा सा it will somehow try to find it. For example, exercise 21.1 is say if psi1 is an arbitrary one particle state, to that probability हमारे पास जो probability है psi1 square is k1 psi square. और हमारे पास k is equal to the expectation value of psi1 a dagger a. This is creation. This operator, which is made of creation and elimination operator, it acts on state chi psi. It will give chi. It's equal to psi1. तो ये exercise हमको prove करनी है. Before coming to this proof of this exercise, I want to basically remind you that you can have any two states, psi, for example, psi in terms of if you want to write psi in terms of psi j, so you multiply it by aij. So aij, if you remember, ये matrices हम लेते थे 2 cross 2, or in the operator formalism we could ये j contract हो जाता है psi I. So there is a procedure by which you can go from state psi to another state psi. Psi I can go to psi j via some operators. And this is this thing. Our question ये है कि how we can have a representation where we can have this creation and annihilation operators को हम कैसे use करेंगे to arrive at जो हमारा जो vacuum state and one particle states ये जो हमने किया था इसमें इस formalism में इसको कैसे हम adjust करेंगे and see how things will pan out. So in the first scheme, what we are going to do is so these we will require these equations. So इसका आप याद रखना है 14 equation है 15 है this is 18 16 17 18. So 15 16 17 18. So might be require all of these equations in the for coming algebra कैसे define to just come to this exercise. So since we don't have space, we just run it off. So you remember it in the meantime. इसको आप हमारे use करना. These equations were nothing. It's how creation and annihilation operators act on the first equation. How creation and annihilation operators acted on the one particle states. जो चौथी इक्वेशन थी how creation and annihilation operators act on the vacuum states. So this was it. So in order to establish the unity transformations, how to relate
सर
two
कुछ
states,
स्टूडेंट्स रिक्वेस्ट भेज रहे
two states,
उनको एलो कीजिए
whether via creation or annihilation operator. क्योंकि हम ये सब state जो था we represented this state as k. Psi को हमने at the end we represented it by k. So you can have k state को हम want to write k state is basically psi state. How can it relate two sides via some unity transformation?
सर स्टूडेंट की वेट करन परमिशन कर
Huh?
कुछ
Yes.
स्टूडेंट्स वेट कर रहे
So they should come on time. Otherwise, I'll not be opening it next time. So how can relate two side states via some operator? Via some operator. So if a state k psi is a state, psi is basically k state को हम ऐसे लिख सकते हैं. In the bracket formalism, हम इसको ऐसे भी लिख सकते हैं. L Q K I. So what is this L2? So normally this is bra or cat. This is operator. If you remember, the LQN and LQSC, it's equal to 1. Its inner product is 1. These are basically two spaces, side. Okay. So it's basically how we can write Ki and Ki, this Aij जो है ना ये हमारे पास unity transformation है. How can this inner product of this this is basically Aij. You can have L, so but here it's I is equal to J. So you can say how can I relate this state vis-a-vis this state by some unity transformation. Okay, if you do it that way, and then complex transformation जो हमारे पास है ये LQKR, we can it forms a unitary matrix. अब हमारे पास जो है वैक्यूम और जीरो पार्टिकल स्टेट phi of 0 is the same whether you take old basis or new basis. So you can have a Fock space or infinite dimensional vector space, but vis-a-vis those different one particle states, two particle states, and n particle states. क्योंकि हम one particle states लेते थे या we can take vacuum states. तो इसमें ये है कि vacuum और zero particle states is the same for new or the old basis. So अगर हमारे पास one particle state नहीं है, so whether the creation operator acts on vacuum states, it will give the zero. Annihilation operator will also give zero. So any two basis states को हम vacuum state में the answer will be same. Phi of 0 will be equal to psi of 0 is equal to this kind of this. अब हमारे पास we'll just take one particle state. One particle state में psi phi q1 will be 0 0 so on and 2. So it will be 1 0 0 0 is equal to L. So we have to introduce creation operators. B dagger and annihilation operators. B of Q. In complete analog of 14 and 15. 14 and 15 means we had in the first equation में हम one particle states को creation operators and annihilation operators के साथ we somehow acted on those states. We can do the same thing here. We can use the symbol B for creation operator and BQ for annihilation operator. So we'll see कि your previous analogy had, using that analogy, how those one particle states will pan out under the once creation and annihilation operators act on them. So they will have this form. So it's B1, BQ dagger, N1, N2, so on and so forth, N2 plus 1. Its creation operator N1, N2, N2 minus 1, N2 plus 1, N2 plus 1. So you can see this N1, N2, this N2 goes to N2 minus 1, so you can have this thing. So either, or you can have for this creation operator, this annihilation operator, this is, so this is one particle state. One particle state में ये होगा कि N2, N3, N4 they don't exist in that Fock space. So in two particle state अगर होगी तो will be N1, N2. Three particle state होगा तो N1, N3. So we are taking one particle states are being acted by creation operators. The same one particle states are being acted by annihilation operators. It will be N2 minus 1, N2 plus 1. So you can have states both इस साइड से भी इस साइड से भी जिस तरह हमारे पास वो आइगन वैल्यूज एंड आइगन स्टेट्स निकलते थे you can say so these eigen values might they represent those states. So अब ये है कि evidently for one particle states the two bases can be connected by, so we have to connect two basis states by some unitary transformation. Two basis states by some unitary transformation. And those basis states they are in turn one particle states. So one particle states can be connected by an equation. So if you have an annihilation operator acting on a vacuum state, you can write it as this Ki can be again. You can write the whole equation by given equation. This is you can write it as 2LQ. This is inner product LQ Ki. So you have related Ki with this Ki via this unitary transformation. This unitary transformation is this, and you can write it as B dagger B dagger Q L2 Ki. Now you have to see this term. So you have related A dagger with BQ dagger. So creation operator of acting on vacuum state with creation operator acting on vacuum state via this unitary transformation. This is also active. So that unitary transformation here. So we have related two bases which with two creation operators. One basis को दूसरी basis के साथ relate किया creation operators A and B. In the same way, we can do the same for annihilation operators also. If इसका permission conjugate करेंगे AI will be A diagonal will be AI. So if you want to write it in, if you want to write it for us compact form लिखेंगे. So AI bracket form sigma Q. It's BQ dagger L2 KI. ये हमारे पास एक इक्वेशन होगी. The next equation will be AI will be equivalent to KI L2 BQ. So you see, annihilation operator related to annihilation operator. There are but two basis states, but this is the unitary matrix by which they are related. Creation, this is a creation operator. This is annihilation AI related to BQ by this unitary operator matrix. Okay. But there are two different bases. एक basis space में है, ये दूसरी basis space में. This is in one basis space. This is in another basis space. So we have got arrived at two equations which relate two annihilation operators via a basis state, two creation operators via some basis state. Sorry, this is a creation operator. This is annihilation operator. So this is the unitary matrix. So this is it. So that base space may be a Fock space, which is infinite dimensional space. अब चूंकि आपने if you remember annihilation operator में थोड़ा सा हमारे पास ये आ रहा था psi ig, if you remember aig psi g, वहां पर हमारे पास a delta function. If I is equal to j, then it's 1, or if I is not equal to j, any other states, it's not going to. So you will have here for vacuum state annihilation operator में हमारे पास delta function आ रहा था. If you remember last equation, so it's like this ki L2 to L2. So you can say it's a product one here. You can see it, but since we are writing it into some operator, so it's ki j. So it's how we can write two states which are vacuum states. How we can relate two vacuum states via some inner product. So it's also one ki. सिर्फ यहाँ पर ये फर्क है ki kg psi of 0. So is psi of 0. अब देखो यहाँ पर ki kg. If I is equal to j, it's 1. If I is not equal to j, it's 0. So here also annihilation operators can also be if states acting on vacuum states. How can relate two vacuum states for annihilation operator? This is given by some that's it. Or you can write it as delta ig. So we have it in delta ig. Yes. अब ये है कि we are writing things in terms of A's and B's. तो A है यहाँ से. अब ये not only we have just like we have related AI diagram with BQ diagram. AI with BQ. Now in the same way we have to relate AI with BQ for this vacuum state also. So here we have done the general scheme, the general vacuum state, two creation operators in two different bases, two annihilation operators in two different bases. Here we are relating two annihilation operators, but in the vacuum state. That's but in two different bases. We are doing the same exercise, but in the we can do the same exercise here in the vacuum state. We psi को हमने यहाँ पर 0. Now the thing is, यहाँ तो हमने किया AI to AI. Now we have to also relate AI with BQ. So the other part is missing. BQ will be on. So BQ to AI, what we are going to do, you are going to see. You are going to see the things like it's sigma q. This is AI psi g one. It's going to be BQ. Ki of L. So we get another psi state like in terms of psi, in terms of phi. You can have this psi and psi t. You can have phi also. Phi of, again we need another transformation, which you can do at your place. Person, how we can how psi can be converted to how bra can be converted to cat, and how cat can be converted to bra. It's a general interface. अब यहाँ पर bras and cats are used how to relate two states in two bases via some unitary transformations. A unitary transformation में ये है, these can be represented in terms of inner products of bras and cats. So in that sense, you can write it like. So one thing is that so it's a basic notion. So now we are going to write it. So it's this entire document, like I said, key है. हम कहेंगे हम इस चीज को हम कहते हैं कि creation of a particle with quantum number k is equivalent to creation of a particle with quantum number ki, any other quantum number, such that L2 ki is a linear superposition. So the operator of equation, this is consistent general variant. तो अब ये है कि how can write in general sense, अगर यहाँ पर creation operator ये है, ये भी creation operator है, या annihilation operator यहाँ है, annihilation operator यहाँ है, but they are two basis states. How can I write, for example, a creation operator or annihilation operator vis-a-vis some creation operator, another creation operator, or another annihilation operator? We can write these can be different. This is the unitary transformation. So AI is related to BI. These are two operators, creation of annihilation operators. This is the unitary transformation, which is also basically written as the inner product of bra and cat. अब यहाँ पर L K Q I है. They will be different states. So we can write further L2 in terms of some common thing. We can write it as again, we can do this exercise. L2 को हम लिख सकते हैं ऐसे L2 MS यहाँ पर and MS किया. So exhibiting the equivalence of one particle states, exhibiting the equivalence of one particle states. One particle basis representation. So you can have, we have done this thing for one particle states, but we can do it the same thing for the many body theory also. Many particles of the different kinds also. That's it. So other assumptions can be valid. जो हमारे पास equation है for creation and annihilation operator, for example, जो हमारे पास ये इक्वेशन है, how can relate AI, this is for creation of annihilation operators, this is for creation operators LQ, BQ. So this is related to this is related to this. So if it's true for one particle states, so it is can be true for n particle states in different bases. अब यहाँ है कि the assumption is the assumption is that we cannot make this assumption for so we'll not go and extend the assumption for एक तो हमने vacuum state के लिए assumption ली थी और one particle state के लिए assumption ली थी. So we will not hold this assumption, we will not necessarily hold for general subspaces. So you can have subspaces of identical particles, or you can have vacuum states. उन पर creation operators या annihilation operators act करेंगे, and we can relate to basis states. So this is the restriction we have imposed. We are not going to extend it for n particle states in that sense. Because these things will ultimately determine how our communication relations and how we can for example in case of Fermi-Dirac statistics and Bose-Einstein statistics, जो उनका है ना कि once we change we have symmetrization and anti-symmetrization. Psi A, psi B is equal to psi B, psi A for Fermi Bose particles, but for fermions, if you exchange the position, so वहाँ एक negative factor, minus factor आता है. So for the restriction of these states, उनका जो algebra है, we restrict here for two creation operators, two annihilation operators, mediated by the symmetry operator, and two basis states. ये तो एक हो गया. The second is we also are going to say how we can relate vacuum state with the vacuum state. That's it. Via two bases. This exercise. And the other assumption is we also put one particle states only, n ones, the other of the same kind. And इस restriction को लेते हुए we can say that we can arrive at, we'll see how we can arrive at Bose-Einstein, this thing, symmetry, and Fermi-Dirac from this thing. So there can be hypothetical particles like quanta हमारे पास, which will violate these fundamental assumptions, जैसे anyons हैं, या many body theory में, there can be other versions of quantum statistics which may be outside the thing. Since we are concentrating on only these two things, so we'll stop here. So, anybody you have to ask anything? Hello? 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 People are listening?
Yes, sir.
So कुछ पूछना तो नहीं है? Should I ask anything you have to ask?
No,
So
sir.
should I
No, sir.
summarize it what I have said?
Yes, sir.
तो summarize हमने यही किया है कि how we can relate creation, दो creation operators via some basis state, via some unitary transformation. या two annihilation operators को हम कैसे relate करेंगे via some unitary transformation. अब unitary transformation जो है in terms of ने Bra and Cat लिखा, ये तो एक part of the exercise है. The other part of the exercise है how can relate vacuum states, two vacuum states via creation operator acting on that vacuum state or annihilation operator acting on vacuum state. You can do anything to act on vacuum, it will give you zero. This is an exercise हमने किया. And we have another restriction, only one particle state. जब हम यहाँ किया N1, N2, so on, so we'll take particles of only one kind दिया. Okay, we do not take. And after doing this exercise, we arrived at some. We did this exercise to show how we can write two states where creation operators in that Fox space जो infinite dimensional space है, vector space है for this quantum state जो इसकी base state है, which is being acted upon by these operators, whether creation operators or whether annihilation operators. अब इसमें at the end है कि doing on those restrictions जो we can arrive at Fermi and Bose-Einstein status by certain हम unitarization को कैसे करेंगे for symmetry and antisymmetric wave function that we can do in the next classes, how algebra of operators we are going to do. We'll stop.
Yes, sir. Yes, sir.
Oh.
Yes, sir.